Alright, here we are, section 2.6, and we are continuing on with looking at proving a few things today. First off, we got theorem 2.2, properties of angle congruence, which just tells us that angle congruence is reflexive, symmetric, and transitive. Those three properties, reflexive, symmetric, and transitive, we've used in multiple ways, and this is just showing us that once again, they can be used for another item. In this case, we're looking at angle congruence. So reflexive, we learn that as one thing equals itself, or in this case, angle A is congruent to angle A, so any angle would be congruent to itself. Symmetric property, if angle A is congruent to angle B, then angle B is congruent to angle A. Just saying it doesn't matter which side of the congruent symbol it's on. If they're congruent one way, they're congruent the other way. And transitive property, if angle A is congruent to angle B is congruent to angle C, then angle A would be congruent to angle C. Since A and C would both be congruent to B, since they're congruent to the same thing, they've got to be congruent to each other. So here we have a proof. It tells us, given that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and angle 2 is congruent to angle 3, prove that angle 1 is congruent to angle 4. So, first off, in any proof, we always start with given information. And so, we want to use given information that we can make another statement from. And if I say that 1 is congruent to 2, we would need another statement in there, or we can put in another part of this given all in one statement here. So I'm going to say angle 1 is congruent to angle 2, and I'm also going to put in there angle 2 is congruent to angle 3, which is given. Now, when we look at this, two pieces of information, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. So notice we've got angle 2 in both of those statements. 1 is congruent to angle 2, and 3 is congruent to angle 2. So since they're both congruent to angle 2, then they should be congruent to each other. So we can make a new statement that says angle 1 is congruent to angle 3. And that's based off of the transitive property. And not just the transitive property, it's going to be the transitive property of congruence, since the atoms are being congruent to each other, not equal to each other. Alright, so angle 1 is congruent to angle 3. So we've done everything we can do with that given information. Fortunately, we got another piece of given information we haven't used yet. It says that angle 3 is congruent to angle 4, which is given. And then if we look at it, once again, we got 1's congruent to 3, 3's congruent to 4. So we have 1 and 4 both being congruent to angle 3. So we can switch over to say that angle 1 is congruent to angle 4, using the same property we used just a second ago, which is the transitive property. Of congruence. To be really specific, you could say the transitive property of angle congruence, but I will take it just transitive property of congruence there. Alright, so that finishes that one because that's where we're trying to get to. Angle 1 congruent to angle 4. Alright, so then got another one. This one's got some numbers in it, so usually it makes it a little simpler to see it if you can see numbers and see the math. So given that measure of angle 1 is equal to 63 degrees, angle 1 is congruent to angle 3, and angle 3 is congruent to angle 4, the measure of angle 4 is equal to 63 degrees. So when we look at the information that's given to us, right, 1 63, we want to prove that 4 is 63. So if we can prove that 1 and 4 are the same, then we can switch over to say that 4 is 63 degrees. So we look at this other part of the given, and these two pieces of the given, 1's congruent to 3, 3's congruent to 4, right? Just like from the last proof, it should kind of make sense. Angle 1 congruent to angle 3, angle 3 congruent to angle 4, go ahead and label my T-chart here, statements and reasons. So now from the last proof we did, this should kind of kind of just stand out to you that 1 and 4 were both congruent to 3. So I can say that angle 1 is congruent to angle 4. And once again, that's the transitive property. Congruence. Right, and we do this over and over enough, then you should start to kind of recognize it when you see the transitive situation there to be able to use it. Alright, so I got that angle 1 is congruent to angle 4, which is not the same thing as saying that the measure of angle 1 is equal to the measure of angle 4. Because notice we want to end in the measure of angle 4 equals 63 degrees. So we need to make a switch here at this point in the proof from talking about things being congruent to saying that they're equal. And since angle 1 is congruent to angle 4, then we can say that the measure of angle 1 is equal to the measure of angle 4. And we know that by the definition of congruent angles. Because if we know the definition of congruent angles, that would say that it's two angles with the same measure. So if they're congruent, they've got to have the same measure. Or if they have the same measure, we know they're congruent. So switching from equal to congruent or congruent to equal, we're going to use the definition of congruent angles here. Alright, so then now the measure of angle 1 is equal to the measure of angle 4. We've kind of run out with everything we do with the steps or the information we have up here so far. So I'm going to bring in the next part of the given, which is what we always do when we can't go any further with the thread of information that we have. Then we look to see if we've got more given that we can put in there. So the measure of angle 1 equals 63 degrees, and that's given. And if the measure of angle 1 equals 63 degrees and 1 and 4 are equal to each other, then I can replace the measure of angle 1 with 63 degrees. So that'll lead me to the measure of angle 4 is equal to 63 degrees. And that's going to be the substitution property. Of equality. Just looking at things that are equal in this case. Okay, and that's where we're trying to get to. The measure of angle 4 equals 63 degrees. Measure of angle 4 equals 63 degrees. So we're ready to move on to the next page of the notes. Alright, so we have theorem 2.3, the right angle congruence theorem. which just tells us that all right angles are congruent. All right, so if I have two right angles, we automatically know they're going to be congruent, which should kind of make sense because all right angles are 90 degrees. But this is just a rule that we can use anytime that we've got two right angles to say that they're congruent without having to say that they're both equal to 90 degrees. So, given that the angle DAB and angle ABC are right angles, angle ABC is congruent to angle BCD, prove that angle DAB is congruent to angle BCD. So, trying to prove that DAB and BCD are congruent. So this angle here and this angle here we want to prove are congruent. And we're given that DAB and ABC, these two angles down here, are right angles. So that's where I'm going to start out with. Angle DAB and angle ABC are right angles. I'm just going to use the abbreviation for angle because I ran out of space there. Alright, so then that's given. And since we know that these two angles are right angles, this theorem right here, the right angle congruence theorem, tells us that those would be congruent. So knowing they're right angles, now we can switch to say that angle DAB is congruent to angle ABC. And that's from the right angle congruence theorem. And so that's all we can do with that first piece of the given. So we look to see if there's more given, and there is another piece of the given. So we can say that angle ABC is congruent to angle BCD. And so since DAB is congruent to ABC and ABC is congruent to BCD, they're both congruent to ABC, so that means that DAB and BCD would be congruent to each other. Except for angle DAB is congruent to angle BCD. I guess I didn't put the reason for 3, but that was the transitive property. Grunts. All right. That's not what that 3 was. That was given. That came from our given. And 4 was actually the transitive property. Okay. So, next one. Theorem 2.4, the congruent supplements theorem, says if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So if angle 1 plus angle 2 equals 180 degrees, and angle 2 plus angle 3 equals 180 degrees, since 1 added to 2 equals 180 and 3 added to 2 equals 180, then 1 and 3 would have to be the same. Right? Because if 2 was 60, then it would take 120 to add to 60 to 180 here. It'd also take 120 to add to 60 to equal 180 here. So the same angle or congruent angles being supplementary with two angles means that those two angles are congruent to each other. All right, and the congruent complements theorem, same idea as the congruent supplements theorem, just If two angles are complementary to the same angle or congruent angles, then the two angles are congruent. So 4 plus 5 equals 9 degrees, and 5 plus 6 equals 9 degrees, and 4 and 6 would both have to be congruent to each other because they both add with 5 to equal 90. All right, so given measure of angle 1 equals 24 degrees, measure of angle 3 equals 24 degrees, and angle 1 and angle 2 are complementary, angle 3 and angle 4 are complementary, prove that angle 2 is congruent to angle 4. Alright, so we have a whole lot of information given to us in the given. So, if 1 is 24 degrees and 3 is 24 degrees, if we know they're both 24 degrees, then they would have to be equal to each other. So I'm going to say the measure of angle 1 equals 24 degrees. Measure of angle 3 equals 24 degrees, both of which came from the given. And then, since they both equal 24, they should be equal to each other. So I want to say that the measure of angle 1 is equal to the measure of angle 3, which would be the transitive property. Of equality this time. Now, we're talking about things being equal right now. We want to end in congruent, so I'm going to switch from equal to congruent. So since the angles are equal to each other, the measures are equal to each other, then I can switch to say that angle 1 is congruent to angle 3. And that's going to be by the definition of congruent angles. Alright, so that's all I can do with that information that I start out with in the given. So now I look for more given information. So I've got angle 1 and angle 2 are complementary. And I also know that angle 3 and angle 4 are complementary. Now, since 1 and 3 are congruent, and 1 plus 2 equals 100 equals 90, or is complementary, and 3 plus 4 is going to be 90, or equal to be complementary, then since 1 and 3 are congruent, it's like I'm adding the same thing to 2 and 4 to be complementary. So this goes back to the information we just learned here. The congruent confidence theorem with two angles are complementary to the same angle. And then this part, or congruent angles, that's what we have in this situation, two congruent angles that are complementary with two angles. Then the two angles are congruent. So, since 2 and 4 are complementary with angles that are congruent, then angle 2 is congruent to angle 4, which is the congruent complements theorem. Alright, so then we got the linear pair postulate, which we've already learned this information, but now we have an actual postulate, a formal rule that says if two angles form a linear pair, then they are supplementary. Right, angle 1 and angle 2 in a linear pair they're going to add up to equal 180 degrees, making them supplementary. Remember, a linear pair is two adjacent angles, meaning that they share one side and a common vertex, and their non-common sides make a straight line or opposite rays. So if you have a set of a linear pair, then the two angles add up to equal 180, or they're supplementary. Next rule, the theorem 2.6, the vertical angles theorem, also a piece of information we learned a little earlier. It says if we have a set of vertical angles, then they're going to be congruent. So vertical angles go straight across from each other at an intersection. 2 and 4, 1 and 3. So 1 and 3 being vertical angles, we know they're going to be congruent. 2 and 4 being vertical angles, we know they're going to be congruent. Alright, so then here, given that angle 1 and angle 2 are a linear pair, angle 2 and angle 3 are a linear pair, prove that angle 1 is congruent to angle 3. So here we're going to start with all the given. Angle 1 and angle 2 are linear pair. Angle 2 and angle 3 are linear pair. Given? So since they're a linear pair, what did we just learn about linear pairs? They are going to be supplementary, right? So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are also supplementary. Which came from the linear pair postulate we just learned. And then if we look at what we have here, 1 and 2 are supplementary, 2 and 3 are supplementary. So 1 and 3 are both supplementary with angle 2. So since they're both supplementary with the same angle, then we know that those two angles have to be congruent as well. So last step, angle 1 is congruent to angle 3. And that is by the congruent supplements theorem. Alright, and that completes the notes for section 2.6.